Yunong Xiao is a senior engineer at Netflix. Yunong, welcome to Software Engineering Daily.
Thanks for having me, Jeff.
You wrote a blog post called Node.js In Flames, and it has a riveting explanation of how you diagnose a problem in your Node.js stack. The story starts with a graph. Tell me a bit about that graph.
Right. So that graph shows our request latency in terms of milliseconds, and so for just to visualize that graph, what we're seeing is that the request latency for a very specific API, which just serves static files off disk, which should be a constant time, go from 1 millisecond to, I think, around 30 to 40 milliseconds within the span of a few hours. And then you see a dip back to a millisecond as we enable rolling reboots within our fleet to reboot the node process to bring back down the latencies. So that was the pathology that we were seeing.
And what node service was this?
This was the Node Packager service, which was a part of the Netflix Node.js stack, which today runs all of the website. So when you go to netflix.com, for example, this is the service that ultimately renders that request for you and brings it back to you on the browser.
Were users feeling any effect from this?
I mean, for this specific API, they were, but it was very, very small because this API was fronted by a CDN. So, only the first request for a particular asset would feel elevated latencies. But in generally, because we had enabled the rolling reboots, this wasn't a big issue in terms of affecting customers.
And at the time, what was the protocol around handling an event like this, a problem in the Node.js stack?
I think so. If I understand your question correctly, are you specifically asking about the protocol around Node or the protocol around how we handle problems?
More like how Netflix operationally would handle a problem in the Node.js stack.
Right. So at that time, Node was very nascent technology at Netflix. This was really the first service to use Node, and it was also an external service. And so, we use some of the same sort of reliability methodologies that we use across the rest of the website. So if we had customer issues, those customers are first and foremost what's really important and most important to us. And so we want to mitigate the customer impact, right? And normally if we could, we would roll back, but unfortunately we had at that time already made the decision and we had already rolled out a bunch of the website to Node. So the only recourse was then to just do rolling restarts until we were able to nail down the root cause of this problem.
The title of this post is Node.js In Flames, and the flames that you're referring to are flame graphs. Talk more about what a flame graph is.
Right, so a flame graph is a visualization tool. And generally, one of the most important ways that it's used and the data that's being visualized is CPU profiles rather. And so what we use, at least in the context of this article, the flame graphs were CPU flame graphs. And what they were showing was the amount of time our code was spending on CPU. And flame graphs, for those of you who are unfamiliar, gives you a nice way to visualize a large set of data. So in our case, what we were doing is we would sample the time we were spent on CPU in terms of stack frames. So every at 60 hertz, we would sample our stack frames from within Node. And as you can imagine, if I ran that for 30 seconds, I would get a ton of stack frames back. And so in order to actually visualize which sets of stack frames were spending all their time on CPU, we use a flame graph. And a flame graph gives you a distribution of your stack frames. And so you're able to visualize that more clearly. And I would go recommend listeners of this podcast to actually go read up on flame graphs. I think there's some really nice explanations because it's a very, very much a visual concept, and it's pretty hard to describe in this audio format.
Absolutely, and I will include a picture in the show notes. Just to put a finer, I think your explanation was great. To put a finer point on it, it's basically, each point on the graph, the y-axis defines how many function calls, how many nested function calls there are. So it's essentially how high the flame has gotten is how many nested function calls there are. If that's correct.
Yes, and then the x-axis shows you the percentage of time that particular set of functions has spent on CPU. So the wider the x-axis, the more time you're spending on CPU. And so if you look at a typical Node.js-based flame graph, you'll see probably libuv. Libuv will probably take 80 to 85% of the x-axis at the very low levels, right? Because most of the time you're spending in libuv, regardless of what you're doing within Node.
So what was the solution to the problem that the flame graph signified?
So with the flame graphs, we were able to see that we had these very, very, very high stacks. And from that, we were able to figure out that the reason we were actually, our request latencies were going up is due to the dynamic nature of our website. So you may have noticed, actually, let me just go back and set some context for this. If you and your friend or your colleagues go to Netflix, you might get very different experiences, and that's because we A/B test quite heavily. And so as part of our new Node.js service, we had committed one of the cardinal sins in software, which is we prematurely optimized, and we wanted to make our routes dynamic. And so we had built in this cron-like task within our node process, which would periodically go fetch this new set of routes and delete the old routes that were currently being used. And so there was a bug in this where whenever we would fetch new routes, we would forget to delete one of the old routes and a very specific route handler. But we would add that new handler back into the set of routes. And so the end result being that we would increase the number of route handlers by 1 every time we would refetch the set of route handlers. And this specific route handler that we were leaking took about a millisecond on CPU every time. And so this is why you could see this correlates very nicely to that increasing latencies graph, because every time we would fetch new route handlers, we would in effect add 1 millisecond of latency to every single route that was part of our Node.js service.
Just so some of the listeners who may not be as familiar with web development, what is a route handler?
So this is a very classic way in which most REST frameworks handle the design of APIs, of the REST APIs. So the way that you would design, the way that you use these frameworks is you would want first to specify the route, a particular route that API is to handle. So in this case, let's say it's /foo. And then what you can do is give a list, in this case in JavaScript, an array of functions. And these functions are called route handlers, or commonly known as middlewares. And the reason why that we provide a set of handlers is because you want to encapsulate specific aspects of the API into functions that can then be composable into other APIs, and so that these are the route handlers that we're talking about here.
This experience compelled you to migrate to Restify. What is Restify?
So Restify is a small, lightweight REST framework built on top of Node.js. And the big reason why we migrated to Restify was the fact that it would give us visibility into our applications. And that I think is the most important reason why we've migrated to Restify.
Restify is a middleware framework. What is middleware?
So middleware is just, at the very basic, it's just a function that handles a particular aspect of an API request on the server. So a typical example could be a middleware that parses your query parameters. And this might be a pre-middleware, right? A middleware that executes before the actual userland code that the user would specify and for a particular API endpoint. You could have another middleware that renders out a request, which is to say, takes some parameters and generates markup that's sent back to the browser. And you could have middleware that fire after that are executed after a request has been sent back, after the response has been sent, such as maybe gathering metrics or writing metrics to the log, things of that nature.
There is a computer science term called currying, and currying, where a large function is broken up into multiple sequential functions. Is middleware an example of currying?
It's similar, right? So I mean, we sort of want to get away from the monolithic aspect of writing code. So we wouldn't want to write one function that handles a specific API. We would want to split these up into multiple functions, and so I think that sort of aligns very nicely to be able to have a set of functions that handles a specific API, because this means that you have a set of you have functions that then you can share across multiple APIs. Because oftentimes a lot of the boilerplate is very similar across multiple APIs, right? I'm always parsing in the request, I'm always parsing in the parameters, and maybe I'm going off to a database to get some state for a particular customer, and then I'm rendering I'm rendering a page based on that information. All of these all of the functionality I've just described here is probably common across most of your APIs, right? So you wouldn't want to have to construct or rewrite a lot of this code for all of your APIs. And so to be able to compose a bunch of functions that then make up one single API endpoint is really helps with code reusability.
How does Restify's application visibility manifest? What profiling and debugging features are within Restify?
Right. So this is, I'm glad you asked that question, because this dovetails very nicely with the problem that we had as part of that blog post. So one of the really important features of Restify is something called an audit log. So this means that for each request that you get as part of your Hdtv server, Restify actually emits an audit log, which contains a lot of pertinent information for that request. So things like the request latency, the request handlers, the response handlers. One really crucial piece of information is that it actually dumps out timing for all of the middlewares that are used for that particular route. And so in our with our problem where we were leaking a request handler for every time we update the set of requests, the request handlers. Had we had the auto log, it would have been very easy for us to see that, hey, this set of request timers, this set of request handlers for all the requests, they keep increasing by one every say 10 minutes, right? So that would have made it really, really easy for us to figure out what the issue was.
Your colleague Brian Cantrell said that production is war and war is hell. How does Restify make production less hellish?
So production is really, really hard because oftentimes you have customers at the other end of your services that are depending on your production services. So when you have an issue in production, you oftentimes aren't afforded any of the luxuries that you would have in a test environment, right? For example, with us at Netflix, whenever we have production issues, our priority number one is to get that production service back up and running, right? We often don't have time to go debug and figure out what the issue is with that service. We need our customers to be back. They want to be happy and they want to watch Netflix, right? And so what's important with Restify is it captures a lot of this information that you'll need often to go do a post-mortem later on, right? So a lot one of the methodologies that we like to use is to be able to post-mortem all of our failures, right? So we can learn from these and ensure that they don't happen again. And in order to be able to post-mortem a failure or an issue in production, you need to be able to capture information about that particular service and what went wrong. And so one of the reasons why we chose Restify is that it gives you a lot of information and it captures all of this information for all the requests that come into your service, so you can later on go and analyze exactly what happened and what went wrong with your service.
How does Restify help generate data that is more helpful? So as part of Restify's metrics frameworks, it gives you a lot of information about your particular request, right? And so you get all of this for free, which means that you no longer need to worry about capturing, let's say, HTTP metrics. But one of the other really key things about Restify is that oftentimes there's always this trade-off in production, right? Do I want to log at a really verbose level, or do I which we as engineers always want to, because we want to capture as much data as possible. But the problem with that is that oftentimes if you log every single stateful object that comes into your service, you end up spending all of your time just logging these objects to disk, and it's quite wasteful. And especially in the happy case, when you don't have any issues, you actually don't want to log this information, right? In the case that you have
an error with your system, that is when you want to log these issues. So restify has something called a request capture stream that lets you accomplish this, where in the happy case, right, we're just logging the bare minimum amount of information. But restify internally captures every single logging statement that you've emitted for all of your requests inside a ring buffer. And so for the requests that do encounter errors, let's say you're logging warnings or errors, or an exception is thrown within the code base, then restify is smart enough to know that, hey, for a particular request, right, we've encountered an error. So for this and only this request, let's dump out all of the trace logging information, because that's for these set of requests, the trace logging is important to be able to postmortem this failure.
Great. Netflix uses Bunyan to get streaming JSON logs. What is Bunyan?
So I think you've described it very well. Bunyan is a Node.js framework, logging framework rather. It's very lightweight, and it outputs your logs in a streaming JSON format.
And what are the benefits of streaming JSON?
Well, one of the key benefits of streaming JSON is that it's very easily parsed by machines. And so because every single logging record is a JSON object, you can use a lot of the off-the-shelf Unix tools to process your streams of JSON, because they're literally just streams of text, right? And so it aligns very well with the Unix philosophy, where streaming text is the common interface. And also, there are a lot of modern tools out there, like Elasticsearch and a bunch of JSON querying tools out there that work very easily with a streaming JSON format. And so, logs are really where we capture most of our state for our service, for our runtime services. And so, to be able to use a lot of these off-the-shelf tools to easily analyze the contents of your logs is very important.
What is a typical workflow for debugging a Node app's streaming JSON logs? Like, you've got a problem. Take me kind of end to end. What it looks like as you're diving into solving the problem.
Sure. So oftentimes we'll get reports from our quality assurance engineers, or we'll get actually reports from our Netflix help desk, which directly interfaces with our customers around, a customer might get a 500 page, right? But what we do as part of every 500 page that we send back to customers is we embed two really specific pieces of information. One of them is the EC2 instance ID of that server that originally serviced that 500 request. And the second piece of information is a UUID, which maps to the request ID of that particular request. So often the workflow for us would be, once we have these two pieces of information, that immediately identifies one, the physical instance that request originated from, and it identifies that request via that UUID. So we can quickly SSH onto that production instance and then grep through those logs for that particular UUID, and that gives us the set of logs that pertain to that particular request, right? And so we can very quickly look up all of that state on why that particular request has failed. And this is very, very key and very powerful, because it means that our engineers and our support personnel can very easily look up why a particular request has failed.
Dtrace is fundamental to the value of restify. What is Dtrace?
So Dtrace is, and again, I am definitely not an expert on Dtrace here. So it's a tracing framework that you can use at runtime, right? So you don't have to recompile your code into in debug mode. You don't have to run any debuggers. You can just use Dtrace to introspect the running state of your applications.
And so, what is the relationship between Dtrace and restify?
So recall that we talked about a bunch that restify captures a lot of metrics, right, for your HTTP request. In addition to doing that, restify has a bunch of Dtrace probes, and you can think of these probes as breakpoints that you can arbitrarily enable and disable while the process is running through Dtrace. And so some of these probes include, when a route handler has started and when a route handler has finished, or when an API request has started and when an API response has been sent. So through Dtrace, we can actually, without having to restart the app, without having to enable debug flags, be able to get timing information for all of our requests of a server. The only caveat with Dtrace, of course, is that you can only run Dtrace on a platform that's where Dtrace is available. So luckily for us, our development environment is on Mac OS X, and because Dtrace has been ported to Mac OS X, we're actually able to leverage Dtrace in our development environment. But as most listeners probably know, Netflix is a heavy user of AWS, and we use Ubuntu Linux in production. And so we've been doing some work with perf events and trying to see if we can get the sort of features that we would like out of Dtrace, but using perf events to accomplish them.
You've quoted Sherlock Holmes as saying, quote, "It is a capital mistake to theorize before one has data. Insensibly, one begins to twist facts to suit theories rather than theories to suit facts." What does it mean to twist facts to suit theories rather than to twist theories to suit facts?
Right. I think we've all done this in the past as engineers, where we have a misbehaving program, right? It could be a service that serves 60 million subscribers like Netflix, or it could be your college CS project, right? But there's a bug, and we really don't know what's causing that bug. And so we start fiddling around with all kinds of different parameters in our software, right? Whether that's operating system parameters or your compiler options or your JVM options, without getting the data first. And software is really, really complex, right? And it's one of the most complex pieces of engineering that we humans have ever created. And it's got millions or hundreds of thousands of knobs to turn. And before you know what the issue is, if you just start randomly turning these knobs, it's really, really difficult to arrive at ultimately solving your issue, right? It's like 1,000 monkeys inside a room randomly typing on typewriters. You're unlikely to get Hamlet, right, to come out. And so what's really fundamental about the way we operate at Netflix is we want to be able to make sure that we have the data before we start just changing and tuning our applications. And again, this is sort of where Restify comes in, because it provides you with a lot of this data as part of its framework. So, for example, a lot of our issues come from like, hey, request latencies are elevated, right? So suddenly now customers, instead of seeing sub 300-400 millisecond responses from Netflix, they're seeing 2 to 3 seconds. And so we want to be able to figure out, well, what's causing the slowdown, right? And without data, you really can't do that. But luckily with Restify, it gives you a lot of detailed timing information about your Node application. So you can easily pinpoint and say, hey, it's because when we go off and make an API request, API is being slow. Or, hey, it's because when we go and render this request, rendering is taking a very long time for whatever reason. But once you've got that data, then you can start to make progress and try to fix these issues. Before you have data, then you're really just looking for you don't know at all what's causing the problem. And if you just start trying to tune all of these knobs, you often end up in a worse place.
At this point, how much of Netflix's stack is in Node?
So to be clear, we haven't really transitioned any of our backend systems to Node. It's really we're really talking about the front end services that serve the UI, so the user experience, right? So we've made a lot of really solid investments in Java, and I think we'll continue to do that for our backend services. And we're all about using the right technology for the right problem, right? And for UI and the user experience, this makes a lot of sense, because most of our user experience engineers are very fluent in JavaScript. They've done a lot of JavaScript, and it doesn't really make sense for them to write their servers in Java, right, which is a language of technology they're not as fluent or familiar with. And so this is where Node became a really great fit for this, because now you can write both JavaScript on the client and JavaScript on the server.
I want to talk a little bit about microservices. How do you define microservices versus the service-oriented architecture?
So I think microservices is all about the separation of concerns, right? It's really about factoring your services into discrete, smaller chunks wherever they make sense. So instead of having, say, a big monolithic service that serves all of our backend needs. So from a user experience point of view, right? Whenever we get a request from our customers, we actually have to forward a bunch of our requests back to our backend services. Now we could do this one of two ways. We could have actually one of many ways, but one of the sort of we could have a monolithic service on the backend that handles all of our requests, which is, let's say, let's get a customer's API allocation, let's authenticate the customer, let's go grab all the metadata for his videos, then let's grab the list of movies that we're supposed to render out to him. We can do this as part of one big monolithic service. But this often, as most people are probably aware of, becomes very hard to maintain. Whereas if we were to split these up into their discrete chunks, which is, let's have a service that only does authentication. Let's just have a service that only gives you back your API allocation. And let's have a service that only gives you back your video metadata. It becomes a lot easier to maintain because you have this natural separation of the boundaries of these services.
And Netflix has a microservice architecture where different services are able to talk to one another with RESTful calls over JSON. This type of architecture is useful because you can write different services in different languages. As you said, the back end is mostly Java. The closer to the front end you get, the more it becomes JavaScript. But all of these services have a common way of talking to each other, which is JSON. How do engineers at Netflix, speaking more broadly or more specifically, I guess, depending on how you look at the question, but how do engineers decide whether a service is more suited to write in Java or restify or some other language?
And again, I think so. One of the ethos of Netflix is freedom and responsibility, right? So for anyone who's read our culture deck, they'll know that this is something that we believe very strongly in. So it's really up to the individual engineers and teams to make this decision. Of course, we've made hundreds of millions of dollars of investment in our Java services stack, and we've got a lot of open source software that we have to show for this. Things like discovery and fault tolerance and a bunch of other frameworks like this. And so I think the reason that we're using Node at this sort of user experience layer is for the reasons I mentioned earlier, which is that because for the majority of the time it's user UI engineers that are building these services and these stacks, it makes a lot of sense for them to work in a language that they're comfortable with, right? And Node also being performant and being great at debugging performance issues really helps with this. But if a team was thinking of running a backend service, right, I think they probably still want to use Java because, again, there's a lot of great engineers here at Netflix who have that experience. We've already invested a ton of time and money into our Java libraries, so it wouldn't make sense to do all of this stuff again in Node.
Let's circle back to the discussion from the beginning. If you would have had restify and the profiling and logging that you get with restify when you were solving the initial problem, how would your approach have changed?
I think that the problem wouldn't have even been a problem because it would have been very clear from when we launched, from day one, really, that we were leaking this specific request handler. I think that was the big issue. Again, so we go back to that quote from Sherlock Holmes, right? Is you got to get the data. Without the data, you're mostly just speculating, and that's why it took us such a long time to find the issue. It's because we didn't have the data. Had we had the data, had we been using restify from the very beginning, then this issue in particular would have been one that would have been very easily solved, right? And you can think of as something like, today we've got like modern MRIs in a hospital, and so when you have an issue and where you can just get a scan and quickly figure out the internals of that issue, it solves a whole class of problems that maybe 100 years ago would have been very, very hard to solve for doctors. So I think of that as the same way as when we switched to restify, it's suddenly a whole host of problems that we used to have with our previous generation of REST frameworks we no longer had because these were issues that we had visibility into that we could fix very easily. So now we move on to harder problems like how do we increase the performance of our rendering engine, or how do we make sure that our requests our services are much more resilient and fault tolerant.
It sounds like you were really able to get a massive leverage from switching to restify. Was that what motivated you to become such a big contributor to the restify open source project? Yes,
that's definitely part of the motivation. Restify, I think, is sort of now become the core and the bread and butter of our stack here at Netflix, and being good open source citizens, we want to contribute back to this framework, right? And so it made sense for us, as we are probably one of the largest users of restify, to contribute back.
You took over restify from Mark Cabbage. Tell me the story behind that.
Sure. So Mark and I both were colleagues at Joyent a few years ago, and Restify really came out of the need at Joyent to again have a REST framework that gave you visibility and metrics into your services. As Mark has now left the Node community, Restify for a while was sort of a little bit stagnant, and it really didn't have a lot of support. And I thought it was really a good time to transition, since I became a lot more involved in using Restify here at Netflix. I think it made perfect sense for us to sort of hand the baton over, and for me to sort of take leadership and maintain the framework.
What is it like to take over an open source project that you didn't start?
I think it's very exciting, but at the same time, there's a lot of what's the word that I'm looking for? There's a lot of responsibility, right? Because I feel compelled to keep the same high level of code quality, the high level of responsiveness that Mark brought to the project, and we want to make sure that we maintain the same ethos, which is, the reason that Restify exists is to be able to provide a REST framework that gives you visibility and observability in your applications, and those are the ethos that we stick by as members on the Restify core team. We want to make sure that as we continue to bring Restify forward and add new features, that they align with the same ethos, which is, this is a production enterprise grade framework that makes it very easy for you to run these production services at scale, because they give you visibility into what's going on.
What are the features that are of highest priority for you to implement within Restify right now?
So I think one of the biggest features that we're looking to add is HTTV2 support. So there's already Speedy support, but since it's been ratified as part of HTTV2, I think it would be very important for us to get first-class HTTV2 support and visibility into that. So that's one of the big projects. The other one is really around WebSockets. We'd love to get better performant WebSockets in Restify. So that already exists today, but performance isn't great, so we would like to improve that. But I think generally speaking, even more important than that for us right now, our biggest concern is to just make sure that the docs are in a better shape, right? Oftentimes, we'll hear a lot of users of Restify say, hey, I really love this framework for the same reasons that we love it and we maintain it, but gosh, the docs make it really, really hard to use. So we're actively working on that as well. And of course, if listeners and viewers out there who want to contribute and help us with any aspect of Restify, just feel free to ping us on the GitHub page.
When you're managing an open source project, this sounds like maybe kind of a subtle challenge. How do you say, maybe you can't tell people to do this, but how do you say, hey, the thing we need to focus on right now is documentation. I know it's not fun to work on the documentation, but we need somebody to do it. Is that a process that you have to delegate to people, or do people just volunteer for it?
I think Restify is in this great position where the core maintainers and the contributors are just driven. They all sign on to the project without us having to recruit them. And I think that's one of the really nice things about open source is the project contributors that you do get, they're not here because they're getting paid to do it, right? They're here because it's what they want to work on. So in some ways that makes it a little bit easier. But in terms of, like you mentioned, the more mechanical, some might say tedious tasks of documentation writing, that largely just comes down to who has time, right? So, as part of the core team, we know that this is an issue, and right now we're just in the process of figuring out what are some good steps towards getting better documentation out there. Is it that we need to maybe contract out and get someone with technical writing experience, or try to recruit someone with technical writing experience to help us out with that? But in terms of managing an open source project, I think because of the pure nature of the fact that people sign on not because they have to, but because they want to, it makes managing and delegating much easier.
And speaking of managing your time, how do you balance the time that you allocate towards your day-to-day work at Netflix with time spent on an open source project that directly improves Netflix if you improve the project?
Right. As most of you know, Netflix contributes very heavily and very openly to open source. I mean, we try to generally open source most of the work that we do. And so that is a very core part of our engineering culture. And because, like you mentioned, Restify is such an important piece of our technology stack, we've actually internally allocated resources, engineering resources towards improving Restify. So for example, 3 out of the 4 members of the core team, which includes myself, are on Netflix's payroll, and we are expected to work on Restify as part of our regular day jobs. So there isn't that balancing act that we have to do where, I can only work on Restify once I get home, where we actually are making active contributions to Restify at work as part of our daily tasks.
Okay, fascinating. So you mentioned HTTP2. There was recently a good episode of Software Engineering Radio about HTTP2. Could you discuss at all what HTTP2 brings? Like, what does the update bring to HTTP?
Right. I think there's some really powerful features. One, which is just around performance, and I think that's part of the reason why we want to use HTTP2 at Netflix. Right, is that it's just much more performant. You're not HTTP2 multiplexes all of your HTTP connections over a single set of TCP sockets, right? So I'm no longer having to instantiate new ones. It gives you full duplex communication, so it's no longer just request and response, right? The server can send me push messages, and it's just a lot more performant in that aspect. So that's really why we want to get HTTP2 support into Restify, is because it's just most new browsers now support it. It's very clear that the internet and the technology space is moving towards HTTP2, and we just want to make sure that we bring full support for that as part of Restify.
And what does the spec look like for bringing that support into Restify? Like how do you plan that sort of project? Hey, we need to bring HTTP2 compatibility to our RESTful framework. That sounds like a hard problem. I'm curious how you manage it.
Right. I think, we sort of stand on the shoulders of other giants in this regard, right? There's already a very excellent Node HTTP2 module that already exists. And so we'll be looking to leverage that very heavily as part of Restify. Restify is designed so that it's sort of really agnostic to the substrate that it's running on. So today it can run currently on Speedy or WebSockets or the default Node HTTP implementation, right? And because it's been designed that way, we can actually leverage other substrates like the Node HTTP2 module. It's just around making sure that the interfaces all fit, and whether we'll have to make some changes to our interfaces such that it's compatible with the Node HTTP2 module.
So you guys are using Restify to render out your views on television or on the screen or whatever. But Restify does not have a core rendering framework built in. How did you implement that? Like, how did you get things to render through Restify? Right.
So previously, before the Restify, we were using a different framework, and that came with a rendering framework as part of that. But because of the dynamic nature of our user experiences, we didn't use that either. We actually have a homegrown version of a I hate to call it MVC because there's so many negative and different connotations attached, but we had an MVC framework, like an orchestration framework that would ultimately determine how we would render out our markup. To be more specific around the technologies, we use React as the framework, as our rendering framework, but we also have this orchestration framework that we use that lets us generate really dynamic user experiences based on inputs to the system. And so this framework is something that we're actually going to release as part of the Restify project. So again, contributing back to open source, and this is something that we strongly believe in. So look out in the next few months as we prepare to get this framework ready for open source, and we'll actually open source that as part of the Restify project.
I'd love to talk a little bit about React, because I think React is going to be increasingly important in the future. What are some tips for building services that are compatible or synergistic with React?
I think with React, and again, I'm sort of not the best person to talk about with React.
Sure. Well, it's a very new technology, so yeah. I think it's fair to talk, off the cuff or however you want to speak about it.
Yeah, and I think a lot of it just comes to. I think for us, one of the biggest concerns that we have with any rendering framework really is around performance, right? And so you have to make sure that regardless of which rendering framework you use, especially because we're doing all the rendering on Node, you have to ensure that you're as performant as possible and you spend as little time on CPU as possible when you're rendering out specific views, right? And so as part of this, our big push in our user experiences in the coming our push in the user experiences going forward is really around isomorphic JavaScript, which is really to say that we want to be able to render some parts of our view on the server and then some parts of it on the client, right? And there's always this trade-off because obviously the server is much faster most of the time at rendering than your client, because of the hardware that's involved. But at the same time, we also want to have that flexibility because it means that we can render less on the server. Because with Node, as soon as you're rendering a UI, which really at the end of the day, all that means is you're hot on CPU and you're replacing strings inside of markup, right? As soon as you're doing that, you block every other request from being able to be serviced because you're blocking the event loop. And so there's always that trade-off. And so we're working towards better trade-offs around that area with isomorphic JavaScript to be able to render some part of the UI on the server and then send that off to the client and render the rest of it on the client.
So are you saying that you're trying to architect a strategy where you can choose to have a lot of flexibility, a lot of agility in if you construct something one way where you're rendering like 80% on the server and 20% on the client, and you want to be able to easily adjust those numbers?
Right, and so to be able to even do some rendering on the client and some rendering on the server, and to be able to adjust the numbers, by definition means that you have to be isomorphic, right? Because it means that I should be able to shift that, turn that dial and adjust it. And if I adjust some parts of it to render on the client, that means that JavaScript has to be able to run both on the client and on the server.
Fascinating. So what is interesting to you in the JavaScript space right now?
I think what's really interesting is just the sheer amount of engineers that is using JavaScript both obviously on the client but also on the server. So if you look at let's just look at Node, what's really exciting is that in addition to a lot of bleeding edge startups who traditionally use bleeding edge and new technologies, we see that Node has been picked up by a lot of bigger and more mature corporations like Yahoo and Intuit and PayPal and Netflix, obviously here. And so that's really exciting because that means that these bigger corporations can contribute much more to JavaScript, and that's really great. Also really exciting that Node's really come a long way. It's become a lot more mature. There's now a Node Foundation, which is great. There's rules of governance. And so I think in the coming years, Node will just move from strength to strength as more users and more sponsors get behind it.
Have you ever heard of Atwood's Law?
I have not.
So Atwood's Law states that anything that can be written in JavaScript will be written in JavaScript. Do you think that's true?
I think that's very subjective. Of course, technically speaking, anything that passes the Turing test, right? Anything that's rather anything that's Turing complete, you can use to eventually write programs with, right? But that doesn't mean that you should, right? I think sort of my philosophy has always been you use the right tools for the job, right? Well, I can go write a search program, a program that searches through text in JavaScript. I'll probably save a lot of time, and they will probably be actually a lot more efficient if I just use grep, right? So it's all about using the right tools for the right job, and I think there are a lot of tasks in which JavaScript and Node.js in particular really excel at, and there are lots of tasks where it doesn't. And where it makes sense to use these technologies is where we should, and where it doesn't make sense is where we shouldn't.
Talking about microservices architecture as a whole a little bit more, what do you think are the biggest problems with microservice architectures that are probably true industry-wide?
I think one of them is actually kind of obvious, which is just around fragmentation, right? And being able to define boundaries. So if you have suddenly a lot of thousands of microservices, one, you need the infrastructure to be able to handle the discovery mechanism around being able to discover all of these microservices. But two, it's really around if I have a lot of microservices, how do I actually delineate and sort of ensure that the right set of functionality is being encapsulated by the right set of microservices, right? That's often very hard, especially given the distributed nature of many of the teams externally here at Netflix. So it's really important to set expectations and make sure that we design these frameworks ahead of time with a lot of thought, such that we don't have two microservices that essentially do sort of the same thing, right?
Do you have any general principles or advice for how you segregate those responsibilities along different microservices?
I think that all comes to sort of when you're doing the initial scoping and design work for a particular service, to really talk with all your stakeholders and all of your customers and all of your engineers to ensure to get as much feedback as possible, right? Because that's how you avoid the sort of problems with design.
What is the future of JavaScript?
I think JavaScript, it's really sort of very popular today, but I think it'll become even more popular. Certainly, it's probably never going to fade from as a client-side language for user experiences in the browser. And we see that there are a lot of apps now today where their native apps are still written in JavaScript, right? And so I see JavaScript moving from strength to strength, not just in the user experience world, but really taking off in the server-side world as well with Node. I think Node really brought attention to sort of JavaScript for a lot of folks who didn't really use JavaScript before, and it gives it gives you a mainstream framework that allows you to write functional and dynamic in a functional and dynamic language, but gives you performance and visibility in a robust runtime.
So to begin to close off, one of the motifs that I want to explore throughout this podcast is the idea that people should be more proactive about taking on bigger sets of responsibilities, taking on bigger projects, and that's essentially one thing that you've done with Restify. Do you have any tips for how people can find opportunities to take on more responsibility and maybe overcome certain self-imposed limitations that they may have on the types of projects that they end up picking up?
Yeah, I think a really key thing here is just do it, right? If there's something that you feel like is lacking with a particular framework, an open source project, just do it. Go ahead and start working on it. Reach out to the contributors, reach out to the maintainers, and say, hey, I'd like to help out, and I think I got some ideas around X, Y, or Z, or whatever you think that's lacking, and just send some pull requests. I think the Git and the sort of the GitHub social coding concept really makes these things easy, right? I think a lot of the sort of recent new features in Restify didn't come from the core maintainers. It came from other folks who use Restify, love Restify, saw that there was a feature that they wanted to add and sent pull requests. And I think that's just a really great sort of way to dip your toe in the water and get involved with open source software.
That's great. All right, well, Yunong Xiao, thank you for coming on to Software Engineering Daily. It was a real pleasure interviewing you.
Thanks for having me, Jeff. It was a pleasure as well.